The 2026 Atlantic hurricane season opened with a storm that broke rules, defied forecasts, and left a trail of flooded communities from Texas to Georgia. Tropical Storm Arthur was not the most powerful storm anyone will remember. It never reached hurricane strength, but what it did and how it did it is something meteorologists will be studying for a long time. And if you want to understand what the rest of this hurricane season might look like, Arthur is your starting point. Let's go back to where this began. Arthur's origins trace back to a tropical wave that combined with the remnants of Pacific Tropical Storm Christina, just east of the Yucatan Peninsula. That disturbance drifted into the Gulf of Mexico, interacted with a frontal boundary over Mexico, and crept toward the Texas coast. On June 16th, the National Hurricane Center designated it a potential tropical cyclone, forecaster language for a system that doesn't yet have a defined center, but is already capable of producing dangerous weather. Then, on June 17th, Arthur officially became the first named storm of the 2026 Atlantic hurricane season, after organizing just off the Texas coast. The numbers were modest. Arthur peaked with sustained winds of 45 miles per hour and a minimum pressure of 99 millibars, barely a tropical storm by definition. And yet the damage it left behind was anything but modest. National Hurricane Center Director Michael Brennan put it plainly: the main threat from Arthur is going to be a prolonged, multi-day heavy rainfall event that could produce dangerous to life-threatening flash flooding. And that heavy rainfall threat is going to persist even after the center of Arthur moves farther inland and dissipates. He was right, and then some. Here is the thing most people still get wrong about tropical storms. When the wind numbers are low, people tune out. They see tropical storm instead of hurricane and they stop paying attention. That instinct gets people killed, because Arthur's danger was never the wind, it was always the water. The National Hurricane Center forecast rainfall totals of 5 to 10 inches, with isolated higher totals near 20 inches across a large stretch of the Gulf Coast through early Friday. That was the forecast. The reality was worse in places. In one rural Louisiana parish, more than 2 feet of rain fell in just 48 hours. 2 locations in Louisiana's Avoyelles Parish, Cottonport and Placerville, recorded 29 and 22.5 inches of rain, respectively. A nearby town, Simmsport, received more than 17 inches. Think about what 29 inches of rain means. That is not a rainstorm. That is a small ocean dropped on top of a town in 2 days. Ground that was already saturated from days of prior rain had nowhere to put it. Rivers backed up, roads disappeared. More than 257 flash flooding incidents were reported across the southeast, stretching from Texas to Georgia, as Arthur's remnants pushed inland. Flood watches were issued for at least 16 million people from South Texas to Central Mississippi. In Texas alone, the numbers were staggering. In Central Texas, dozens of roads closed to flooding. At least 20 people were rescued from floodwaters in Waco. Over 100 low-water crossings shut down across the Austin area, and a driver swept away attempting to navigate a blocked crossing had to be rescued in South Austin. Texas Governor Greg Abbott issued a disaster declaration covering 101 counties before the storm even made landfall. In Louisiana, the preparation was visible, but the damage still came. New Orleans Mayor Helena Moreno said police were preparing boats and setting up barricades in known flood-prone areas, with sandbag distribution sites opening across the city. In Avondale, just across the Mississippi River, a tornado wrecked 4 homes. One tornado was confirmed in Avoyelles Parish, along with 3 others near New Orleans. That brings us to the threat nobody saw coming, or at least the one most people ignored. Tropical systems carry a hidden second weapon: spin-up tornadoes. They are not the dramatic, visible funnels most people picture from the Great Plains. They are small, fast-forming, and completely wrapped in rain. You cannot see them coming. At least 4 tornadoes broke out along the Gulf Coast as a direct result of Arthur, part of a broader outbreak that caused damage across the Midwest simultaneously. And 10 tornadoes were confirmed in central Georgia alone as Arthur's remnants pushed eastward. That is not a footnote. That is, a significant outbreak inside a storm that most people had already dismissed as just rain. The timing of these tornadoes matters enormously. The peak threat from spin-up tornadoes in tropical systems often comes overnight, when people are asleep. A warning measured in minutes is the hardest to act on at 3 in the morning. If you live anywhere in the southeast and a tropical system is in the region, you need a way to receive alerts that will physically wake you up. A weather radio, an alert-enabled phone, something. The absence of a dramatic wind number on the news is not safety. Now, here is where the science gets genuinely interesting. Before Arthur made landfall, there was serious discussion among meteorologists about whether this storm would do something extraordinary, survive its trip across the Deep South, and then reorganize off the Carolina coast. There is a documented mechanism for how this can happen, called the brown ocean effect. When land is completely saturated with water and a summer sun beats down on it, the moisture evaporates upward almost exactly the way a warm sea does. It hands the storm the same hidden energy, the latent heat that the ocean provides. Under the right conditions, soaked land stops acting like a death sentence for a tropical system and starts acting like a fuel tank. The conditions for exactly this were assembled along Arthur's path: an air mass loaded with moisture, ground already soaked from days of prior rain, and strong June sunlight driving evaporation. The historical precedent for this behavior comes from 2007, when a storm called Aaron reorganized and actually deepened over Oklahoma, hundreds of miles from the Gulf, stunning the forecasters watching it. So what actually happened with Arthur? The National Hurricane Center tracked Arthur's remnants for possible redevelopment off the U.S. East Coast as the storm moved northeast. However, strong upper-level wind shear and Arthur's merger with a nearby frontal system ultimately prevented reorganization off the southeastern coast. The comeback did not materialize the way the most aggressive model runs had suggested. AccuWeather had noted that while there was a chance Arthur would regain some strength off the Carolina coast, another possibility was that a non-tropical low-pressure area would form from Arthur's residual moisture over the Atlantic. The shear won. The storm did not reload, but the flooding did not stop just because the center fell apart. Flooding risks still threatened more than 63 million people on Friday, with forecasters saying another 1 to 3 additional inches of rain could fall in cities like Atlanta, Birmingham, and Jacksonville, days after landfall. From a storm that technically no longer existed as a tropical system, the system rolled across Georgia, the Florida Panhandle, and the Carolinas, producing widespread rainfall of 5 to 10 inches with isolated totals up to 20 inches. By the time the damage assessments came in, at least 4 people had been confirmed killed and estimated damages exceeded $100 million. That is the final ledger from a storm with 45 miles per hour winds that spent most of its life as a disorganized blob of rain. There is a broader picture here that deserves your attention. Arthur developed over sea surface temperatures above 83.5 degrees Fahrenheit off the Texas coast. The Gulf was running hot, and running hot early. An overheated Gulf is not just a full fuel tank for storms. It is one that resists being emptied, because warm water runs deeper than a thin surface layer. Storms that churn up cold water from below to cool themselves cannot do so effectively when the warmth extends well below the surface. Meanwhile, Colorado State University actually reduced its 2026 Atlantic hurricane season outlook as El Niño officially arrived. El Niño tends to increase wind shear in the Atlantic, which suppresses hurricane development. And yet the season opened with Arthur forming ahead of schedule over an unusually warm Gulf, producing life-threatening floods before the calendar even reached the heart of hurricane season. That is the central question Arthur leaves us with. If the opening act of a season suppressed by El Niño already produced this kind of flooding, this kind of damage, this level of complexity, what does the peak of the season bring? August, September, and October are when the ocean is hottest, when the atmosphere holds the most moisture, and when the most powerful storms in history have formed. Arthur was, in meteorological terms, a weak storm, It was supposed to be routine. The forecast cone you see on television, the one that shows where the storm center is going, does not show you where the rain falls. Arthur taught that lesson again this June, as it has been taught every few years in one form or another. The rain falls far beyond the cone. The tornadoes spin up inside the rain. The flooding happens on ground that was already wet before the storm arrived, and the communities that were not in the path were underwater by Thursday morning. Watch the water, never drive into a flooded road, and keep your weather alerts on through the night. This season is just getting started.